Okay guys, I wanted to briefly show you a run of the Infinispan cross-site test that I wrote in our Boston lab. So the test can be downloaded, it's on GitHub, this is the URL. All the configuration files that I'm going to show are part of the test, so you can try this out yourselves. Let's take a brief look at the configuration. So the project is very simple. We have a test driver and we have a bunch of configuration files. Let's take a look at Infinispan.xml first. So here we define the site. The local site is London, but this is parameterized. So we're going to have a London, a San Francisco, and a New York City site. And this site here happens to be London, but we'll see how this is used in the startup scripts. Down here we have under defaults, we have the sites configured. We have backup sites, which in this case would be San Francisco and New York City, but this can be configured in a startup script. Let's actually take a look at the startup script. So this is the startup script to start up London. The site would be London and the backup sites would be San Francisco, New York. Similarly for San Francisco, the site here would be San Francisco and the backup sites would be London and New York City. Okay, back to Infinispan. Let's take a look at the backup site London. If London is a backup site, the failure policy is warning. The strategy is async. That means X-site replication is going to be async. But in our test, we're going to use dist sync to actually replicate the elements within the local site. All right, we're going to use a cache called clustered cache. It's distributed, as I mentioned. It has 2 owners for every item, and it is synchronous. I also make this cache transactional. The logging mode is pessimistic. I haven't tried optimistic yet, so maybe this is one of the things I want to try out. If we look at the configuration of the local site, this is done here. The transport is basically site.xml, and site would be London XML, San Francisco XML, or New York City XML. Let's take a look at London XML. The only difference between these 3 XML files is actually the address and the port. So London is running on the multicast address 230.111 and port 50,000. New York City is running on 230.333 and 52,000. The main point here is that we're trying to separate the 3 clusters, the 3 sites. So New York City should not see traffic from San Francisco. San Francisco should not see traffic from the other sites. If we go to the bottom, we have a relay configuration, which basically makes sure that we're connecting to a global bus. So every site connects to a global JGroups bus, and that bus replicates changes to the other 2 sites. Okay, so I've set a test up in our Boston lab, and the setup is we have 9 machines, and we're going to run London on cluster 1, cluster 2, and cluster 3. This is a site. And then we're going to run San Francisco on cluster 4, cluster 6, and cluster 7. And we're going to run New York City on cluster 8, 9, and 10. So let's start cluster 1. This is basically running a Maven script to start the test. Our address is cluster 1 62278, and you can see this is run in London. And since we're the so-called site master, that's the coordinator of a local site who's responsible for forwarding messages to the other 2 sites, we're also creating a bridge cluster that is based on a global configuration, on TCP-based configuration. So the site master has been started. Now let's run the 2nd node and the 3rd node, and you will see that they actually form a cluster. I can press 2 in this in this application that prints the current view. So we see the current view is cluster 1, cluster 2, and cluster 3. There's a bunch of things we can do here. We can set the sender threads in number 3. We can set the number of RPCs. By default, we're sending 10,000 requests. R sets the read percentage. 10,000 requests means if with a read percentage of 80%, we're basically 80% of those requests are gets and 20% are writes. And this can be changed, of course. We can print the contents of the cache, we can clear the cache, we can set the message size. The message size is currently 1K. So when we press 1, what the driver will do is it will run 10,000 requests for random numbers between 1 and 10,000. So every iteration will pick a random key and do either a put with a 20% chance or a get with an 80% chance. So before we do that, let's start the other site. So now we're starting up San Francisco. The site master is up. Second node. Third node, we're doing the same for New York City. First node is up. Starting the second node and the third node. So now we have 3 sites, basically 3 clusters that don't see each other, that contain 3 nodes each. When we now press 1, what we're going to do is we're going to write roughly 2,000 elements that are, because we're using dist sync, this is going to be replicated in a transaction to this node and this node, and the site master is also going to forward that or relay that to the site master of San Francisco and the site master of New York City, and they're going to replicate or distribute the data to their own local clusters. So let's do that. We press 1. So remember, this is going to be 80% reads, but the keys are not existing yet, and 20% write. So we see we wrote 2,000 keys into the local site. So when we press 6 cluster size, we see we have roughly 1,000 elements. This guy has roughly 1,200 elements, and this guy has roughly 1236. Because we wrote around 2,000 keys, we should be, and we have num owners, we should have around 4,000 keys in that local site. And if we add up 1,200 and 1,200 here and 1,200 here, this adds up to roughly 4,000. But if we go to the other cluster, which is completely autonomous, San Francisco, we'll see that its cache is actually filled as well. We can see here we have elements as well, and here we have elements as well. And the same goes for the New York site. I can actually look at this last member. Okay, so now let's actually pre-populate the cache. This means if we press 9, this means we're going to write keys 1 through 10,000 into the cache. And so subsequently when we do a write, we're going to write to an existing key, but when we do a get, we're going to read from an existing key. And so this is warming up the cache. You can see here we have 6,700 elements. Here we have 6,644 elements. And here we have 6,656. If we add those numbers up, 6656 plus 67 plus 6644. Oops, that's wrong. Let's do that again. 6656 plus 6,700 plus 6644 is 20,000. Exactly 20,000 keys. That's 10,000 keys times 2 over replicated over 3. And if we go to San Francisco, to the second node, and press size, we'll have elements there as well. So now let's run that performance test a couple of times. We're running 10,000 elements. We see that with a read rate of 80%, we have roughly 8,300 requests, that is transactions per second. Every transaction is synchronous within the local site, and the replication to the backup sites is asynchronous. And we can see that here we had 7,800 reads and 2,100 writes. If we do this a couple more times, you can see that we have roughly between 8 and 9, or here even 10,000 requests per second. If we change the read rate percentage to 100, of course, then things are going to be much faster. You can see this is only a local read. We have 138,000 requests per second. If we change the read rate to 0, then we're only doing puts, and of course, then things will be slower. You can see that we have around 2,100 requests per second. We can go to any node in the cluster. Let's go to the third node in cluster London and do this, and we'll see the JVM needs to warm up a little bit. We have 4,700 requests for a read ratio of 80% to 20%. And if we do this a couple of times, you can see that that number actually gets up to around 9,000. We can go to any node and do this. So what happens here is the read is always going to be local. So this will be the San Francisco site. The read is always going to be local, and the write is going to be replicated to both the London and the New York site. So you can see this needs to warm up, of course. 4,000, 6,000, 9,000 requests per second. We can also change the dist sync to dist async. So if we press S, that's going to toggle sync to async, and then things are going to be a little faster. This, of course, needs to warm up as well. And you can see we get these numbers up here. Okay, so this is basically my little demo. This can be downloaded, as I said, and you can try it out yourselves. Feedback appreciated to the Infinispan mailing lists.